Well, hello, here we are running our Who's Counting lab today. And just a little bit of background, this particular lab is going to help us learn how to do a counting by weighing method. Because we cannot always see or physically handle what we are trying to count, we can count them in a method of weighing by figuring out the weight of a sample. We can determine or at least predict how many particles we may have. So we're basically going to be discovering how chemists count atoms and molecules within this particular lab. And we're going to do that using rice grains and navy beans. Now you should have already answered these pre-lab questions, which we will review in a live meeting only. Now on to our lab. Remember that you should have tried to write a hypothesis about whether you feel rice grains or navy beans would produce more accurate results by the counting by weighing method. And again, that will be reviewed in our live meeting only. So in part A, we first need to figure out the average mass of both rice and bean grains. So I'm first going to label and weigh two dishes. You can see I've labeled one dish with A and 10 and one dish with 20 and B. The letters will come along later on. Then I needed to measure and record the mass of each weighing dish, and you can see here that each dish weighs exactly the same at 1.29 grams. And so we would fill this in here with 1.29 grams. And I'm going to fill this one in as well since I went ahead, just kidding, since I went ahead and masked them both now. Now, this next part has us placing an appropriate number of individual rice grains into each weighing dish. If you weren't sure what that came from, it comes from right here, the sample size of 10 for this first section. And then the other one has a sample size of 20. So here in this picture, you can see that the mass of 10 grains is 1.46 grams. And our mass of 20 grains is 1.65 grams. So moving back here to our lovely table of data, I am going to simply put 1.46 grams here and 1.65 grams. And then I'm going to go back and double check that I did that correctly. And I did. Excellent. Okay. Next step here is to figure out our samples, our sample size mass. Okay, and that's simply subtracting the weighing dish away from the weighing dish in sample. And so I do believe that that would be us taking 1.46 and subtracting away 1.29 to come up with dun, 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 a mass of, do you have it? Did you bring your calculator to this here lab? You should have. Just like you should be filling in all of this information as we are moving through together, because I will help you do everything for rice and then make you do it yourself for the navy beans. And so the final answer in this particular case is going to be 0.17 grams. Now, I need to do the same thing here, and in which case I would take the 1.65, which was my weighing dish and sample, and subtract away the dish at 1.29. And did you calculate that yet? Have you figured out exactly what this should be equal to? And did you get 0.36 grams? Excellent. Next step here is going to be for us to figure out the average mass of one particle. Now, an average mass means I'm going to take the numbers that I have calculated above for the sample mass. So that would be, in this particular case, 0.17 grams for a total of 10 grains. If I then divide by that 10 grains, that is going to tell me what the average mass of one rice particle, one rice grain, would be. And so in this particular case, if I took 0.17 and I divided it by 10, I should get 0.017 grams. And I really would like everything here to be rounded or reported to the nearest hundredth of a gram. So this is then going to be rounded. We are going to round to 0.02 grams. So this is our rounded answer. This is the more correct answer here based on the uncertainty of our equipment. Okay, our balances only go two places past a decimal, and therefore our answer should be reported as such. And likewise down here, since we got a mass of a 0.36 for all 20 grains, I then need to divide this number by 20 to calculate out exactly what we believe the average mass of one rice grain will be. And in this particular case, I get 0.18 grams. Just kidding, I do get 0.018 grams, which then again, if I am going by all rounding rules here, rounding rules apply, my answer is 0.02 grams per individual rice grain or particle. Now here, the average of averages is pretty easy to calculate. Remember that an average of averages is the two added together and divided by 2, because there's only 2 averages we are trying to then average. That's a lot of averaging. All right, so again, in this particular case, you would take 0.02, and we're going to add that to 0.02, and we're going to get 0.04, and then we're going to take that answer and divide it by 2, which inevitably is going to give us an answer of 0.02. And that is the average mass of one rice particle. And we are going to be carrying through with this information into part B, because now that we know the average mass of one particle, we should be able to carry that through to figure out the next portion of this lab. Before, however, we do that, before we go through here and have you move on to part B, I would really like it if you could just fill everything in here now for your navy beans. And I'm going to show you that slide and let you record your own data. Here it is, folks. Weighing dishes are still the same mass, but here's the mass of 10 navy beans versus the mass of 20. You should be able to fully calculate and fill in this entire section with information for navy beans and figuring out the mass of one single particle on average of a navy bean. Do remember that this is a recording, so if you feel like I'm going too fast, you can rewind it and play it back as many times as you would love to hear my voice. Moving on to part B. In part B, here we have the counting by weighing method, and this means we have to take and predict the mass of 100 particles. Well, if one particle was 0.02 grams for rice, I would simply multiply that by 100 and find out that 100 particles of rice should be 2.00 grams. Since my weighing dish is 1.29 grams, if I were to try to weigh out a sample size of what I believe to be exactly 100 particles, this would come out to be 3.29 grams. I am simply adding these two things together. So the very next thing I'm going to do is to put my dishes on the balances, and I'm going to add rice to them until I reach my, in this first case, 3.29 grams. And then when I do, I'm going to count out exactly how many grains of rice I have. I've sectioned them out into groups of 5 for you to help in your counting. Please feel free to count now. Okay, once you've got that in here, you have counted this up. You should have found that. And right in here, I'm just going to repeat the fact that my sample really did weigh 3.29 grams. I saw that in the picture. And when I counted it, I found I had 114 particles. Okay, and then we're going to repeat this whole process so that I can make sure I've done it correctly. So again, the weighing dish was 1.29 grams. The weighing dish and sample, remember we're getting the sample up here because 100 particles should be 2 grams, should come out to 3.29 grams. And then I'm going to go ahead and add rice to that until it comes out to be 3.29 grams. And then I'm going to count those particles. And so in this second, the right-hand side, I've sectioned them off into 5s to help you count them. And hopefully you've come up with the same number I did, which was 116. So when I was counting sample 1, I got 114. When I was counting sample 2, I got 116. And so now I have been able to figure out, using the counting by weighing method, how many rice grains were actually in my sample. I would now like you to do this entire portion of this lab with the navy beans. So you have to put in the predicted mass of 100 particles based on part A for navy beans. The weighing dish is the same, so 1.29 should be effective. And now I will show you the weighing dish and sample. This is sample A. Came out to be 16.33 grams, and here's the number of particles of beans in this dish. And again, here it is for the second section, part B. Here is the mass, and here are the number of beans. Now, the masses for the beans may not be equal to exactly what it was supposed to be, but you had to get as close as you possibly could to the projected mass from the data table. Now, please go forth, complete the data table for the navy beans in both sections A and B, and then complete all of the discussion questions. You have to answer them in full sentences. Show work for all calculations. And then, before you attempt to turn it in, look through this rubric to make sure you are capable of turning in your finest product. Good luck to you all.